Alright. يعطيكم ألف عافية يا جماعة. اليوم احنا رح نبلش with a different drug class واللي هم البيتا لاكتامز which is a very large drug class of antibiotics. يعني I'm sure إنه as a term antibiotics مر عليكم. By the way, it's not a term that is only used for خلينا نحكي الانتيبكتيريals. حتى كمان those anti-cancers which come from natural sources are also called antibiotics. All right. طيب هلا as we have started before, the drug classes اللي احنا عم نحكي عنها they are classified based على mechanism of action. So definitely before we go into the class of the beta lactams in terms of a structure, the characteristics, the chemical characteristics, يعني whatever is involved or related to the structure, we need to talk about the mechanism of action. وحتى كمان نحكي عن the mechanism of action, we need to have a good background about what they inhibit. البيتا لاكتامز يعتبروا inhibitors of cell wall synthesis. That is why we need to talk about, let's say, the synthesis of the cell wall. Okay, what enzymes are involved in that, variations ما بين الجرام positive والجرام negative عشان later on نعرف لما نحكي عن optimization of penicillins ايش الchanges اللي انعملت حتى مثلا to widen the spectrum of activity. ايش الchanges اللي انعملت في الستركتشر for resisting the effect of beta lactamases. فdefinitely this background that we will talk about, even though مش راح يكون فيها أو مش راح يكون في direct questions about whatever we will start with, لكن it's very important for you to understand when we later talk about the optimization of penicillins. تمام؟ طيب هلا you all know إنه البكتيريا, all right, besides the cell membrane that we also our cells have, they are surrounded by what is known as a cell wall. Okay, a cell wall, which, for instance, if you look at this cross section of a gram-positive bacteria, this purple structure is what represents a cell wall. احنا رح نحكي عن the constituents of the cell wall, the enzymes involved. طبعا مش كلهم. The one that we are interested in, which is the target of beta lactams and what they do. Okay, the overall structure of the cell wall. هلا cell wall for bacteria is very important. It protects the bacteria from any changes in osmotic pressure in the environment surrounding it. It gives the shape of the bacteria, okay, for the rods, for the staphylococcus and so on. The high shapes are dictated by the cell wall. And there are other functions that are mediated by cell wall. طبعا احنا مش موجودة عندكم بالسلايدز بس أكيد this is not the focus of our lectures or our class. طيب ما بين الجرام positive والجرام negative bacteria, those two, let's say, major subclasses of bacteria, which is based على الجرام stain, okay, something you definitely came across بالmicrobiology. The variations بالstain is due to the variations in the cell wall. Okay, هلا ليش الجرام positive والجرام negative بيختلفوا بالstains أو when they أو بالcoloration they present when they are stained with the gram stain. This is due to the variations in the cell wall. Okay, هلا بالgram positive bacteria, which stains violet when using the gram stain, it has a very thick wall of a very thick, let's say, layer of the cell wall. For gram-negative bacteria, it has a way more complicated structure. Now, this purple part in here, which represents the cell wall, it's way much thinner relative to that seen in a gram-positive bacteria. Okay? لكن it has an extra part in its outer envelope, واللي هي another cell membrane, or let's say an outer membrane. The cell wall of a gram-positive bacteria as if it's exposed, let's say, to the outer environment. بحالة the gram-negative bacteria, the cell wall is present in what is called a periplasmic space, which is in between the outer membrane and the inner cell membrane. Okay? هلا يعني بالسلايدز عندكم شويه detailed خلينا نحكي constituents of the cell wall انه بيكون في عندي let's say teichoic acid and all that. يعني نهائي ما don't worry about those. Okay, what matters to us ما بين the gram-positive وال gram-negative bacteria, the thickness of the cell wall, and that the gram-negative bacteria has an outer membrane. And the only thing we care about for gram-negative bacteria اللي هي الporins. Okay, لأنه هاي الporins is what was, let's say, exploited حتى إحنا نعمل broadening للspectrum of penicillins. يعني early أو first generations أو early generations of penicillins كانت فقط, let's say, mostly affecting the gram-positive bacteria. It had no activity against the gram-negative bacteria لأنها ببساطة because of the outer membrane was not able to enter and reach the cell wall. Okay, the changes اللي انعملت بالstructure allowed those penicillins to enter through the porins and get to the periplasmic space where they were able to interact with the enzymes involved in cell wall synthesis. Okay? طيب. هلا the cell wall, all right, is composed of a peptidoglycan. طيب, when I say peptidoglycan, معناها the compartments of this structure, of this framework of a structure, is what? يعني what do you think what constitutes a cell wall is? Sugar, it definitely has a sugar part, and let's say a peptido part, okay? هلا, what you see in here, okay, is a خلينا نحكي a small segment of the cell wall where you see layers that are on top of each other, where they are cross-linked with each other, okay? هلا, the circles you see in here represent the glycan chain, which is composed of NAM and NASH. We will, let's say, see those structures in the later slide. هلا, NAM comes from it a peptide chain, right? هلا, that peptide chain, which we call a stem, bound to one of its amino acids, a bridge that is called a glycine bridge because it's mostly composed of a glycine amino acids. And these, let's say, cross-link with the amino acid in another stem coming from another layer of the cell wall or the peptidoglycan. Okay? It's the cross-linking, that process of a cross-linking اللي رح نشوفها later on, that's the target. That process is the one that is inhibited by inhibiting the enzymes responsible for this step. That's the crucial part that we are interested to talk about. Before we go into the details of the structures of the cell wall of the peptidoglycan, let's say, layer, we need to understand in a gram-positive and gram-negative bacteria, the monomeric parts, اللي هي sugar part and the polypeptide chain that is linked, let's say, to the sugar part, those monomers are synthesized inside the cell, okay? And then they are extruded to the outside of the cell membrane, okay? And in the outside, let's say, environment of the bacteria, this is where the transglycosylation and transpeptidation occurs. أو in other words, بيصير في عندي linkage ما بين sugar part, that process we call it a transglycosylation, and cross-linking ما بين peptide, let's say, stems and bridges. This is also happens outside. يعني the monomers of the peptidoglycan are synthesized inside the cell, then they are transported to the exterior, and in there, the linkage and, let's say, خلينا نحكي polymerization of the glycan part and the peptide part happens outside of the cell. Okay? طيب, the enzymes responsible for those two processes will be present where, you think? Yes, outside the cell wall, which makes them vulnerable to the effect of the those inhibitors. Okay? هلا, enzymes that are responsible in particular about or for the cross-linking or a linkage ما بين peptide bridges are called collectively penicillin binding proteins, because they were discovered based على inhibitors اللي أو خلينا نحكي their discovery did not come before the inhibitors. يعني it's the inhibitors that led, or the discovery of beta-lactams is what led eventually to the discovery of those proteins. فعشان هيك سموهم penicillin binding proteins. Okay, طبعا there are so many different isoforms of those penicillin binding proteins. Alright, احنا مش رح نحكي عنهم او مش ضروري انه نعرف ال exact isoforms of those penicillin binding proteins. You just need to understand انهم they are called penicillin binding proteins. So the target for beta-lactams are penicillin binding proteins. Many of those isoforms are responsible for transpeptidation. It's this step that is inhibited by beta-lactams. And when inhibited, معناها ما راح يصير في عندي cross linking ما بين let's say the peptidoglycan layers. And when this is inhibited معناها إنه such, let's say, a structure ما راح يكون في عندي أو ما راح يكون very strong, and for sure eventually it will lead to lysis of bacterial cells. Okay, meaning that beta-lactams are bactericidal or bacteriostatic. Cidal for sure. طيب نرجع نحكي هلا عن ال exact structures of the building blocks for the cell wall. هلا حكينا إنه sugar part is composed of NAG and NAM. طبعا these are abbreviations of sugars. NAG stands for N-acetyl glucosamine. من الاسم معناها if I say glucosamine, so it definitely resembles the glucose, لكن one of the hydroxyls is replaced by an amino group. And that amino group is, as you can see, what is added to it. هاي الجروب كلياتها as a substituent إيش بسميها؟ acyl. Okay? وin particular acetyl. لما تكون عندي, let's say, composed of 2 carbons. So this substituent is called an acyl, generally speaking. Specifically, it's called an acetyl. That is why the name N-acetyl glucosamine, because that acetyl is connected to the nitrogen. Okay? هلا, the other glucose part of the other glucosamine part is called N-acetyl muramic acid, because we have an extra, let's say, group which is called muramic acid. تمام؟ طيب هلا attached, and for sure those NAG and NAM are connected via, do you know what we call this linkage? A glycosidic, let's say, bond. 1,4 because the bond is between a hydroxyl or between 2 hydroxyls at position 1 and 4, 1 in NAG and 4 in NAM. Now, extending from the NAM unit, a peptide chain. طبعا before the cross-linking, this peptide chain is composed of 5 amino acids اللي هم alanine, glutamic acid, K stands for what? Lysine, alanine, and aniline. 5 amino acids, okay? هلا via or following the linkage or the cross-linking, this alanine is, or this terminal alanine is eliminated. هاي رح نحكي عنها, بس نحكي عن ال exact mechanism of action of beta-lactams, لأنه before that we will definitely go into the exact process or the exact, let's say, cross-linking كيف بيصير عندي inside the active site of the enzyme. We will leave that for later. Okay? So originally, building blocks or the stem of the polypeptide chain that is connected to the NAM is composed of 5 amino acids. The last amino acid, or the terminal alanine, is the one that is eliminated following a cross-linkage. Okay? The cross-linking بصير ما بين the glycine bridge that is usually connected to the lysine and the penultimate alanine. The penultimate معناها الامino acid that comes before the last one. All right? But what is D, you think, stands for? هلا الامينو acids are chiral molecules. Yes, and all of them except for the glycine. لأنه alpha carbon في عندهم. the amino acids are chiral. Okay. طيب chiral معناها definitely I have two stereoisomers. The one that is present in our cells اللي هو ال طبعا you all know انه خلينا نحكي the previous assignment of the configuration for amino acids واللي still للآن على فكرة used اللي هو الD والL. alright? Yes. هلا ال natural amino أو natural amino acids have what configuration? ال L ولا D? ال L. Okay? D stands for the configuration of, let's say, the amino acids that they are right next to it. يعني مثلا glutamic acid here has a D configuration. All right? طبعا there is a reason for such occurrence. حتى تحمي السيلز from the peptidases سواء كانت its own peptidases أو حتى الhost peptidases. Okay? لأنه definitely البeptidases راح يكونوا specific for which configuration? ال L configuration. ال D راح يكون resistant للhydrolysis. That is why they are present in the D configuration. عفوا. Yeah, بالstem peptides, all right, اللي موجودين عندي بالcell wall, they are actually present in a D configuration. Okay. كل هاي لا طبعا لا يعني it's خلينا نحكي for the ones we come across. يعني مثلا لما حكينا عن الكاينيز inhibitors DFG موتيف كنا نكررها دائما. فit's important for you انكم تعرفوا مثلا D and F and G stands for what. Okay. For this part in here very important انكم تعرفوا ال A وال K stands for what. وin particular ال A اللي هو الألانين. Okay. لأنه رح نحكي عنه later on بس رح نحكي عن الميكانيزم of action. يعني فقط what is related to الكورس بس انكم تعرفوا ال 21 amino acids يفضل بس it's not a must. طيب هلا let me quickly show you what يعني exactly happens when cross-linking occurs عشان أفرجيكم let's say that these processes are catalyzed by penicillin binding proteins وليش البيتا لاكتامز inhibit that process. بس we'll definitely go through that يعني حتى لو ما أنا شرحت كل شيء هون don't worry about that because I will go over that very thoroughly أو خلينا نحكي in a detailed way بس نحكي عن ال mechanism of action of the beta lactams. All right? طيب what you see in here is a segment of the peptidoglycan of the cell wall. These are the glycan part, the NAM and NAS unit. Okay, this represents the stem peptide before being cross-linked. طبعا زي ما حكينا the linkage ما بين the sugar part, this process is called transglycosylation. This process is also catalyzed by different kinds of enzymes. These are not, let's say, still يعني I haven't seen in literature targets أو خلينا نحكي drugs that target that process. إحنا اللي interested فيها regarding البيتا lactams is the transpeptidation. Recall حكينا إنه اللايسين is connected to a glycine bridge. هلا سواء كان represented in this manner اللايسين لحاله أو إنه a glycine bridge at the end راح يكون في عندي أنا amino group. Okay. هلا the other stem peptide where cross-linking will occurs حكينا إنه أنا في عندي two alanines, right? هلا two alanines will be connected via what? Peptide bond, which is shown in here. Okay? فالترانسبeptidation ببساطة هي عبارة عن a nucleophilic attack from the amine على الأمide where this amine now will be linked to this carbonyl of the penultimate alanine. As a consequence بتطلع عندي let's say a terminal alanine. Okay, that's the overall thing that happens for transpeptidation. هلا this process is catalyzed by penicillin binding proteins. لكن the process is more complicated than that. يعني راح أشرح عنها بس نحكي عن الميكانيزم of action بس I will briefly mention it here. هلا صح احنا حكينا إنه بصير في عندي simply breakage of that amide bond والأمين now will be linked to that carbonyl. All right, لكن this process first needs activation from the enzyme. الانزيم فيه a serine residue that will itself attack الاميد bond وبتطلع عندي التيرمينال alanine. بصير هلا الانزيم نفسه bound to the carbonyl of the penultimate alanine via an ester bond واللي هي بتكون more electrophilic, which will make it easy now for the nitrogen of the lysine أو the glycine bridge to attack that ester وبتنكسر هاي الباند. برجع عندي الانزيم free وبتتكون عندي هاي البيبتايد bond ما بين ال different stems giving rise to transpeptidation. We will talk about that in more detail later on, so don't worry about it. يعني I just wanted to show it to you يعني حتى تكون somehow عندكم فكرة عنها before we go into خلينا نحكي ال other, let's say, compartments of the cell wall structure. Okay. هلا البيتا lactams that have a structure very similar to خلينا نحكي ال penultimate and terminal alanine. That is why they bind to those penicillin binding proteins. والenzyme mistakenly thinks or خلينا نحكي mistakenly binds to it لأنه في عندي similarity كبيرة بالتشابه. And this would make those penicillins covalently bound to penicillin binding proteins. This is what later will inhibit the transpeptidation أو ال cross linking اللي بيصير عندي في البيبتايد وجلايكان. بيتكسر عندي the structure of the cell wall and lysis of the cells happen for bacteria, and this is how the antibacterial effect of beta lactams is mediated. طيب هلا again ال variations ما بين ال gram positive وال gram negative is that the gram positive has a much thicker, let's say, peptidoglycan layer, right? That of gram negative bacteria, peptidoglycan, as you can see, is much thinner, لكن it is protected or it has an outer cell membrane, okay, that has porins, and through those porins is what leads to the passage of small, highly polar molecules. That is the basis للmodifications اللي انعملت later to enhance the water solubility of penicillins وتخليها تصير effective against the gram negative bacteria. طيب any question regarding the cell wall structure؟ يعني صح احنا بنحكي بديتيلز كثيرة بس what you will be asked about in the exam is way much less than what is explained. بس يعني ضروري تعرفوا ال variations ما بين gram positive gram negative the main structure of the cell wall لأنه understanding that will help you to understand how beta lactams act. طيب لما أحكي lactam, what does this indicate? أو lactam stands for what? Yes, a cyclic amide, okay? As you can see in this part. هلا لما نحكي بيتا جاما دلتا lactam. Exactly. It indicates the size of the ring. هلا you all know in organic chemistry for any carbonyl بغض النظر aldehyde, ketone, ester, aldehyde, no matter what that carbonyl derivative is, the carbon that is adjacent to the carbonyl is designated alpha. The one that is, let's say, next to it, beta, gamma, delta, and so on. Okay? هلا when we say beta lactam معناها إنه the covalent bond for generating that cycle is between the carbon that is beta to the carbonyl with the nitrogen. Okay? What is the size of this ring? And how would I, let's say, describe it? Is it 5-membered ring ولا 6-membered ring? 4-membered ring. Okay? طيب. خلينا نحكي a newer nomenclature of the beta lactams اللي هي الازيتيدينون. Azitidinone, يعني if you hear or if, for instance, you read in literature a beta lactam or azitidinone, both, let's say, names are synonyms. They are referring to this ring structure. Azitidinone comes from azitidine, which is a 4-membered ring that has a nitrogen as one of its, let's say, atoms, وأوكسو أو on stands for having a carbonyl on one of the carbons. أوكي؟ هلا البيتا لاكتامز اللي احنا راح نناقشهم بها الكورس، يعني خلينا نحكي for the next few weeks، اللي هم البنسلينز، cephalosporins، طبعا البيتا لاكتاميز inhibitors، carbapenems ومونوباكتامز. All right? All of them, all of those subclasses of the beta lactams, كلياتهم they bind to the same target. They act in the same manner. The mechanism of action for all of those drug classes is the same. Okay? هلا, it's very important for you to understand that the core structure of penicillins varies from one subclass to another. Okay? هلا, المونوباكتams is where I have only the beta-lactam ring, nothing fused to it. لكن the rest of the beta-lactam subclasses, they actually have fused rings or rings fused to the beta-lactam. Okay? هلا, when this ring is a thiazolidine, this one or that ring system is called a penam. A penam is simply a beta-lactam fused with a thiazolidine ring. All right? Penam is the core structure in all penicillins. Cephalosporins have a 6-membered ring that is attached to the beta-lactam, and this ring system is called a cephene. That's the core structure in all cephalosporins. هلا إذا حفظتوا those two rings, okay, it would be, in particular, in names and the structure for them, it would be very easy for you to خلينا نحكي extract ring structures in terms of name, in terms of how they are structured for the rest of the other classes. Okay? هلا لما أحكي penam versus penam, شو الvariation ما بينهم؟ طلعوا على two structures, penam و penam. Yes, and we have a double bond between carbons 2 and 3 in here. Okay? وusually الألكين إيش إحنا بنستخدم في النيمينج لإلهم؟ When in, exactly. That is why the penam versus the penam, the A was substituted with an E to indicate that I have a double bond. طب الcarbapenem, زي الpenam, we have a double bond, all right, ما بين carbons 2 and 3. Yes, what was it substituted with? A carbon. That is why it's a carbapenem, because the sulfur at position 4 was substituted with a carbon. All right? دايما الnumbering بغض النظر ايش هو الدرug class دايما ببلش from nitrogen where it is designated number 1. Only في المونوباكتامز البيتا كاربون is designated number 2 وهيك بنكمل الترقيم. ضروري جدا نحفظ الترقيم. اوكي؟ هلا بالother ring systems for sure nitrogen is given number 1, yet the carbon in the fused ring that is adjacent to the nitrogen, that's the one that is given number 2 وبنكمل الترقيم, let's say in this manner. Any question up to this point? طيب. This structure in here represents what? Cyclobutane, okay? When one of the atoms is substituted with a nitrogen, azetidinone, okay? آسفة, azetidine. Now, look at the 3D structure of those of azetidine. Is it planar? Is the cycle planar? لا, it is buckled. يعني there is some buckling or there is, let's say, some angle in between or dihedral angle ما بينهم. That is higher than, let's say, 0. All right? طيب. الأزيتيدينون أو البيتا لاكتام. Look at the 3D structure. Yeah. In particular, in nitrogen, the carbonyl carbon with oxygen, as you can see, are all on the same plane. Right. This indicates, look at the hydrogen that is attached also to the nitrogen. All of them are on the same plane. This indicates what? What is the hybridization of this nitrogen? sp2. Okay. طيب بما انها sp2 طبعا for sure في عليها lone pair صح؟ اللون pair برأيكم موجود in which orbital؟ p orbital بالضبط. It is present in a p orbital that is parallel to the p orbitals of the carbonyl, which allows for what? For resonance, or in other words, for delocalization of those electrons. Okay, so the lone pair on the nitrogen is parallel to the, which is present in a p orbital. يعني سوري يعني على ال representation الغلط، بس بالكيمدرو ما فيش let's say رسم لل p orbital, only for ال hybridized orbitals. Okay, it's parallel to the p orbitals of the pi system ما بين الكربون والأكسجين, which means that this will, or there will be delocalization, or those 4 electrons will be distributed ما بين these 3 atoms. طيب, when the beta-lactam is fused with a thiazolidine ring, as in the case of pinam and also in pinam, برضو كمان بالcephalosporins, look at the 3D structure of the pinam ring. When a nitrogen, it's the one in blue. Does it look like it's planar to you? Here's another, let's say, representation. لا, لو planar كان بيكون هذا اللاين, let's say, the same as this one. يعني sorry, إنها, let me show you this part in here. Okay, does it look like it's planar? It's more like a tetrahedral shaped. Okay, which means, you know, the lone pair of electrons is present in an orbital that will not be parallel to the p orbitals of the carbonyl. Okay, which means in let's say delocalization is almost يعني highly inefficient, which means in almost the lone pair of electrons راح يكونوا عندي localized على هاي النيتروجين. طيب, there are 2 consequences of that. But before this, let me ask you 2 questions about the beta-lactam in, or the amide group in the beta-lactam. هاي الكربون, هل بعتبرها أنا highly electrophilic؟ طيب, relative to this structure, مثلا برأيكم مين more electrophilic? This carbon or the carbon in the beta-lactam? مين more electrophilic? يب. هلا صح النيتروجين عم تسحب electrons inductively, لكن at the same time it's donating electrons via resonance. يعني هاي النيتروجين عم تعطي electrons للكربونيل كربون. وthis donation of electrons via resonance بيزيد ولا بقلل من partial positive charge؟ بقلل منها. Okay, which means انها راح تكون more or less electrophilic. Less electrophilic. More or less reactive to nucleophiles. less reactive. لما تكون عندي less electrophilic معناها مش رح تتفاعل بشكل, خلينا نحكي good with nucleophiles. Which means, is it resistant ولا liable to hydrolysis? Somehow resistant. طيب خلينا نقارنها هلا في البيتا-lactam when a thiazolidine ring was fused to it. partial positive charge على هاي البوند أو الكربونيل كربون برأيكم مقارنة بالبيتا-lactam more or less؟ مين بيوافقها؟ The electrophilicity of this carbonyl carbon in this structure, بالبينام structure versus that of the beta-lactam, المونو beta-lactam. more. بالضبط. لأنه already حكينا إنه الأوربيتال ما بيكون completely parallel with the p orbitals of this carbonyl. ما راح يكون في عندي good donation of electrons. خلينا نفترض إنه almost ما راح يكون في عندي donation of electrons to this carbonyl carbon. فالalmost the only effect of this nitrogen إنها عم تسحب electrons من هاي الcarbonyl carbon. which means إنه partial positive charge عندي راح تكون أعلى، electrophilicity راح تكون أعلى، reactivity with the nucleophiles راح يكون كثير يعني أعلى. Which means إنه البيتا لاكتام in pinam ring more or less susceptible to hydrolysis versus a beta lactam more. Okay? بسهولة ممكن ينكسروا. Okay? رح نحكي عنها لأنه this is the base for الactivity أو الantibacterial activity of the beta lactams. ورح نشرح عنها بشكل مفصل بس نحكي عن الميكانيزم of action. طيب إشي ثاني. النيتروجين in beta lactam is it acidic or basic؟ ولا neither؟ almost neutral. Okay? يعني ال pKa يعني to begin with that proton الاسيديتي له جدا ضعيفة. النيتروجين here اللون pair of electrons اللي عليها is almost let's say donated to the pi system. يعني in other words النيتروجين here اللون pair of electrons مش localized عليها. فعشان هيك احنا بنعتبر النيتروجين in an amide almost not basic. Okay? لكن نطلع على النيتروجين في هالبينام رينج لأنه صار اللون pair of electrons let's say almost localized. delocalization بصير almost not present. that is why this nitrogen راح تكون عندي البيسيسيتي لإلها مقارنة for that in beta lactams أو الcyclic amides in general بتكون كثير أعلى. Okay, which means إنها if present in acidic conditions ممكن يصير لها بروتونيشن ولا لا؟ وارد جدا انه يصير لها بروتونيشن. عشان هيك البيتا لاكتامز او طبعا البينامز او البنسلينز والسيفالوسبورينز بالاسيديك كونديشنز almost اوكي بيتكسروا. if exposed to acidic conditions ممكن يتكسروا ببساطه لانه النيتروجين بصير لها protonation و this leads eventually to the hydrolysis of the beta lactam. برضه كمان رح نحكي عنه بشكل مفصل later on. Yes. Which structure? This one for the pinam ring مقارنة with this one. يعني they have خلينا نحكي almost some يعني يعني to tell you the truth إني أعرف exact difference ما بينهم لأ بس I would consider them almost the same. يعني ممكن تعتبري البيتا لاكتام في البينام مقاربة بالإلكتروفيليسيتي للكيتون وحتى ممكن تكون شوي أعلى لأنه أنا في عندي نيتروجين عم تسحب إلكترونز من هاي الكربون فبتزيد من الإلكتروفيليسيتي حتى أكثر. يس. فيا بعتبرهم مقاربين أو slightly more البينام رينج. Any question up to this point? طيب هلا another let's say perspective via which we can consider إنه ليش ما بيصير في عندي resonance. إحنا already حكينا إنه الاوربيتالز ما بيكونوا let's say completely أو perfectly parallel to each other to allow for electron delocalization. إنه if you would think about إنه لو صار في عندي resonance okay معناها إنه هاي رح الباند رح تصير let's say a double bond والhybridization here will be sp2. What is the bond angle ما بين attachments on a sp2 hybridized atom؟ يعني كم لازم الباند angles تكون؟ يفترض تكون 120 okay in a four-membered ring. يعني احنا بنحكي عن huge variation عن خلينا نحكي the most stable bond angle for an sp2 hybridized atom. يعني هون تقريبا بهاي الرينج مقاربة ل 90. There's a huge difference ما بين 90 وما بين ال most stable geometry which is to have a geometry أو a bond angle of 120. this adds to the high strain اللي this ring أو this resonance structure اللي يفترض إنه يكون موجود فيه. فعشان هيك it's because of the high strain on this resonance structure حتى لو صار بيكون its contribution very minimal to the hybrid structure. this is one way we can presume إنه almost delocalization أو resonance ما بصير لأنه لو بده يصير resonance the other resonance structure resulting is very strained highly unstable على الأغلب ما رح يتكون معي. طيب هلا في البيتا لاكتامز والبنسلينز يعني I'm sure إنه كلياتكم تعرفوا الستوري behind it. Fleming discovery of let's say penicillins via watching an agar plate that was contaminated. يعني he did not plan to grow الفنجس بس كان petri dish نسوه في الانكيوبيتر over 3 days فصار في عندي contamination from a fungus. هلا لاحظ انه what is around let's say that fungal colony انه انا ما في عندي ولا اي let's say bacterial growth. يعني هو already what was let's say to be grown on that agar plate is bacteria لكن after contamination he noticed انه ما في عندي any growth around that let's say خلينا نحكي الفنجس او الفنجل colony. طبعا بجوز لو حد ثاني مسك الاجر بليت وسكته it's contaminated بس يعني في هيك مقولة جدا مشهورة بالعلم انه a chance discovery favors prepared mind. يعني حتى كمان اللي اكتشفوا الاشياء via chance لو انهم مش واعيين وصحيين ومتنبهين و they have let's say the curiosity to understand and investigate كان ما وصل لها let's say الديسكفري. أنا بس حبيت أفرجيكم البيبر. هاي صورة من البيبر اللي نشرها سنة ال 29 where he explains his finding وهاي ال actual image of the agar plate that was contaminated with let's say this fungal colony. هلا البنسلينز هيك إشي by default موجود بحياتنا يعني بس at that time it was a life saving. والرحلة من سنة 29 لما اكتشفوهم للأربعينات لما صارت البنسلينز available للناس يعني رحلة طويلة جدا. فيعني it's a great discovery. يعني بيعتبر by the way من الديسكفريز بالعالم اللي غيرت let's say حياة الناس. طيب هلا يعني by looking at let's say the structure of for instance this first naturally occurring أو خلينا نحكي isolated natural penicillin, this one, okay? For sure, it's a very complicated structure. هلا the studies have shown إنه actually this or the species that synthesize the penicillins, they synthesize them from 3 amino acids: valine, cysteine, and alpha amino adipic acid. تمام؟ هلا those amino acids via the enzymes of the fungi they are converted into what is known as isopenicillin N. تمام؟ Now, isopenicillin N, the side chain اللي موجودة is not the one, that's actually not the one that was isolated. The first isolated penicillins اللي هم penicillin V, okay, وpenicillin G, sorry إنه هنا مش مرسوم. أو البنزل penicillin أو penicillin G. Where السايد تشين بس خليني ارسم السايد تشين. Sorry. It has this structure. And I mean by the side chain what is attached to this nitrogen. Now, that side chain does not come from fungi. It actually comes from carboxylic acids or acetic acid, let's say derivatives that were added to the media. لو هاي الأشياء ما انضافت للميديا كان اللي فصلوا isopenicillin أو 6 amino penicillinic acid. Okay? لكن what was isolated, part of it comes from خلينا نحكي chemicals كانوا يضيفوها للgrowth media of the fungi. And when they found out that صاروا يغيروا ب الأسيتيك acid derivatives اللي ممكن تنضاف على الميديا حتى يطلع معاهم other derivatives of natural penicillins. احنا فقط اللي راح نناقشهم ورح نحكي عنهم اللي هم البنسلين G وبنسلين V لكن there are penicillin N, penicillin O مش رح نحكي عن their structures. Okay? I just need you to understand that the penicillins are synthesized from fungi from 3 amino acids to give rise to isopenicillin N. Actually the side chain in penicillin V, G وحتى other natural penicillins it comes from acetic acid derivatives that were added to the media. It does not come from the fungi itself. لكن still احنا بنعتبر penicillin G و penicillin V natural penicillins completely synthesized by the fungi. طيب, the precursor of البنسلينز اللي هو 6 amino penicillinic acid which has this structure except for يعني الفاريشنز انه انا ما بيكون في عندي a side chain او there's nothing او خلينا نحكي the nitrogen on carbon number 6 does not have an acyl group او an amide group attached to it, only a free amino group. هلا having let's say this precursor gave rise to خلينا نحكي a building block to vary البنسلينز. يعني they isolated this precursor. الactivity له by the way قليلة جدا جدا. لكن when this compound is reacted with the proper خلينا نحكي an acyl group, it would give rise or we can vary the side chain the way we want to change the potency or to affect the potency, pharmacokinetic properties, the spectrum of activity and all that. Okay? هلا resulting penicillins احنا بنعتبرهم synthetic, semi-synthetic ولا natural? Semi-synthetic because the precursor comes from nature or fungi. لكن what side chain I'm adding actually comes via a synthetic pathway which is done in lab. Okay? طيب. هلا for penicillins as drawn in here, do we have any ionizable groups in the structure? Okay, بس هاي usually happens in خلينا نحكي highly acidic conditions. Yes, what I mean ionizable at physiological pH. Yes, الcarboxylic acid in here. That's an ionizable group. The pK لها تقريبا 4 point something or يعني around 4 in the range of 4, which means at physiological pH it will be definitely ionized. Being ionized أو an ionizable group معناها I can constitute or formulate salts out of it. Okay? To prepare يا إما طبعا I can change the solubility of the salt حسب الcounter ion. هلا لما يكون مثلا الكاونتر ايون صوديوم على سبيل المثال او sorry بس if it's sodium for instance او in case كان على سبيل المثال potassium او for instance calcium, these salts السوليبيليتي لهم مقارنة بالparent compound higher. يعني this graph in here represents the water solubility over time. All right, for the one in green represents اللي هو free acid. تمام؟ If it's formulated as a salt, calcium salt أو potassium salt أو حتى sodium salt, لاحظوا كيف بتكون السolubility أعلى versus that of the parent أو the free acid. Okay? لكن if the counter ion, for instance, is a lipophilic molecule such as the benzathine أو the procaine, yeah, it will lower, or such a counter ion will lower الpolar أو water solubility أو it will increase the lipophilicity of that salt which would become in terms of solubility أقل من that of the free acid. Okay? طيب هلا الكاونتر ايون أو على سبيل المثال البنزاثين مع الفري acid إيش تتوقعوا لما ينضافوا على بعض؟ أو to begin with على سبيل المثال الصوديوم salt, how is it generated from the free acid? لا. To abstract that proton, بالضبط to abstract that proton شو بحتاج أنا؟ base, right? Okay? Such as what for instance? الهيدروكسيد. فعلى سبيل المثال الفري اسيد بضيف عليه صوديوم هيدروكسيد right الهيدروكسيد will abstract الوتر بيعطيني مي والصوديوم will now form ionic interactions with the carboxylate. All right. هلا البنزاثين it's a basic molecule. وين عندي البيسك atom فيه؟ Yeah, those two nitrogens in here. Aliphatic nitrogens ال pK لهم تقريبا 9. When added to the free acid شو راح يصير عندي؟ البيس will abstract the proton of the carboxylic acid. It will become protonated with a positive charge, where it will now form an ionic interaction with the carboxylate. البنزثين since إنه it has two basic units معناها each of those molecules can make or can form, let's say, salts with two molecules of the carboxylic acid or of the free acid. طيب البروكين, where is the atom that is basic that will interact with the carboxylic acid? Yes, this tertiary amine in here. This nitrogen for sure, it's not basic because the lone pairs are, let's say, withdrawn by a resonance. All right? Any question up to this point? طيب. مش الملح. الفree acid itself with the benzathine أو البروكين, they will interact with each other, okay? Yep, and الbenzathine will become protonated, the free acid will become deprotonated, negative charge, positive charge, and they will, let's say, have an ionic interaction with each other. طيب خلينا نوقف هون اليوم على أساس إنه إن شاء الله المحاضرة الجاية نبلش with a خلينا نحكي يعني موضوع يعني still we are in the penicillins والبيتا-lactams لكن راح نبلش نحكي عن liability to acids and bases والmechanism of action. هلا اليوم الأحد والاثنين مش راح يكون في محاضرة بس راح أنزل لكم تسجيل بهاي المحاضرة. يوم الثلاثاء والأربعاء راح يكون في let's say revision للتسجيل اللي نازل وراح أبلش كمان بمحاضرة جديدة. تمام؟ يعطيكم ألف عافية. اللي موجودين أونلاين في أي حدا عنده أي سؤال يا جماعة؟ Any question?